So we've talked about decoupling the expected utility from the expected value of a consumption good. And we'll want to recognize that when we do this, when we talk about expected utility, we're going to have to evaluate utility function using numbers, which suggests cardinal measurement, but we'll just use those numbers to rank so that we're still using ordinal measurement. What I want to do is to talk about consumption under three different situations: a consumer who is risk neutral, a consumer who is risk averse, and a consumer who is a risk lover. Okay, so let's start with the risk neutral consumer. Okay, and what we'll say about a consumer that's risk neutral is this. We'll say a consumer is risk neutral if she has a constant marginal utility of income. Okay. In this case, in the case of a constant marginal utility of income, we'll say that the expected value of a payoff of whatever asset or consumption or good we're looking at, the expected value of the payoff is equal to the expected utility from the payoff. Okay. And I think these terms will become clear as we work through this. So an example of a utility function for a risk neutral consumer would be utility is equal to X. X is the good that's being consumed, okay? And so let's suppose that a consumer faces two gambles. Gamble A, they get $50 with certainty, not much of a gamble. And so given our utility function, we can say the utility from that $50 gamble is $50. Okay. So let's draw a picture of this. So what I'm going to do is put utility here and the value of the gamble down here. Okay. So we're thinking about a utility function, which there's only really one good of interest. There may be other goods consumed, but we'll assume that they're being held constant, their values. So in this case, the consumer gets a $50 gamble, a payoff of $50 with certainty, and the utility of that is $50, or is 50 utils. Sorry. That's gamble A. Now let's look at gamble B. Under gamble B, consumer gets, say, an income of either $0 or $100, and the probabilities associated with those values are 0.5 and 0.5. We can find the expected value of the gamble. 0 times 0.5 is 0, 100 times 0.5 is 50, and so the expected value of the gamble is 50. We can also find the utility of the gamble. So we can find utility of X. The utility is just equal to X. So the utility of 0 is 0. The utility of 100 is 100. And if we take the utility of X times the probability of X, 0 times 1/2 is 0. 100 times 1/2 is 50. Oops. And this gives us the expected utility of x, which is 50. And so in this case, the expected value of the gamble is exactly equal to the expected utility from the gamble. In this second case, in gamble B, there are two possibilities. The consumer gets 0 or they get 100. Let me bring this over. And so if they get 0, then the utility is 0. If they get a payoff of 100, then the utility is 100. The utility function in this case is a straight line. It is linear. Utility is equal to x. Okay. And if we ask this consumer, would you rather get $50 with certainty or take this gamble where you get $50 half on average, $100 half the time and 0 half the time? This consumer says, well, let's see. If I get $50, I get a utility of 50. If I get 0 half the time and 100 half the time, I get a utility, an expected utility of 50. I don't see any difference. I'm indifferent between the two. And so in this case, the consumer is indifferent between gambles with equal payoffs. Okay. So that's one case. The second case is a consumer who is risk averse. You'll note that averse does not have a D in it. They are. A risk averse consumer has a diminishing marginal utility of income. And so a utility function that has this property that we'll use is utility is equal to the square root of x, or x to the 1/2 power. Okay. So let's draw a picture of this before we talk about the gambles in this case. So in this case, if that's x and utility, if utility is equal to the square root of x, then the utility function is going to increase at a decreasing rate. It's going to look kind of like that. Okay. So this is utility equals the square root of x. And let's suppose this consumer faces the same gamble, the same pair of gambles. Gamble A is $50 with certainty, x equals 50 with probability 1. The utility of that $50 gamble would be equal to the square root of 50, which is 7.07. Okay, so that says if you get $50 with certainty, the utility associated with that has a value 7.07. The second possibility is gamble B. In gamble B, has a payoff of 0 or 100 with equal probability. We already know that the expected value of that gamble is $50. We figured that out in part A. Let's take a look at the expected utility. we take the utility of each payoff. Utility of 0 is 0. The utility of 100 is 10. And then weight by the probabilities. A half times 0 is 0. Half of 10 is 5. And so the expected utility of x is 5. So it appears that for a risk-averse consumer, given $50 with certainty or an uncertain payoff with an average value of $50, they're going to prefer the certain payoff because it has a higher utility than the uncertain payoff. Graphically, what does this look like? Well, let's see if I can find my straight edge. I know it's under the file. Or not. So, well, let's do this. You could have a payoff of 0 with utility of 0. You could have a payoff of 100, in which case you'd have a payoff of 10, right? 0 and 10. We can connect those 2 points. When I connect those points, this point and this one, I get this thing, and this red line, which connects the 2 points, is called the expected utility. If you call it the expected utility frontier, we'll just refer to it as representing expected utility. And so the expected utility is a linear combination of utility of 0 and a utility of 10. It's this. And what we found is that with an expected value of $50, the expected utility that's associated with it is 5. And so given a choice of a gamble with a certain $50 payoff or a gamble with an uncertain payoff but an expected value of $50, the consumer prefers the certainty. And so this risk-averse consumer prefers to avoid gamble B and would instead opt for gamble A if given the choice. This is a person who looks to avoid uncertainty. Okay. So that's our second type of consumer. And the third then would be a risk preferrer. That may or may not be the right number of R's. And so for a risk preferrer, this is going to be a person with an increasing marginal utility of income. And an example of a utility function with an increasing marginal utility of income would be U is x squared. Okay. And suppose this person faces the same sort of gamble. I'm going to use different values here because it's a little bit easier to work with different values in this case, but we'll make the same points. Gamble A is an income of $5 with certainty. Probability is 1, so that's certain outcome. And that means that the utility of gamble A is 5 squared, 25. Let's draw a picture. So here's 5, and the utility function, U is x squared, looks kind of like this. It increases at an increasing rate. And so at a utility of 5, I'm sorry, at an income of 5, the utility is 25. Okay. Let's look at gamble B, which has income of $0 or $10 with equal probability. We can see that the expected value of the gamble is 0 plus half of 10, which is 5. Let's find the expected utility of the gamble. So the utility of 0 is 0, the utility of 10 is 100. And if we take the utility times the probability, we get 0 and 50. And so the expected utility of this gamble is 50. So in this case, a certain $5 gives less utility than a gamble that pays off $5 on average. What does this look like graphically? Payoff of 0, payoff of 10. At a payoff of $10, the utility is 100. And again, if we connect these 2 points, 0 and payoff of 100, if we connect those with a straight line, what we see is that when the expected payoff is $5 under uncertainty, the expected utility is 50. And so in this case, the expected utility from the gamble is greater than the utility of the certain $5. This is a person who would prefer to take on more risk rather than to avoid risk. All right, I'll stop there. We'll come back and talk about the beginnings of the insurance part.